Hi dears, welcome to my channel. Today we are discussing some numerical problems in 9th lesson gravitation. This is for class 9. So in the last class we have discussed gravitation thoroughly. So in this class we are discussing some numerical problems in gravitation. What are the important things we have to be in our mind while solving the gravitational numerics? The important things are, first read the question thoroughly. Sometimes even though we are reading, the things will not be in our mind properly. For that purpose, what we have to do? We have to underline the important terms in the question. Okay? When we are discussing questions one by one, we will come to know about it. So first point and the main important point in the lesson gravitation is, when you are getting a numerical problem, underline the important terms which you have to find out. Okay? Second one is, draw a diagram if required. In the lesson gravitation, the diagram drawing plays an important role because it helps you to find the way to solve the equation problems. From the third one, the things are very easy for us. What the third point is, write the non-values. The fourth point is, convert if there is sign conversions. And the fifth point is, then write the unknown values. Then the sixth point is, write the formula through which we can solve the problem. Okay, so by this way we will be able to solve any problems in gravitation, and it will be very easy for you to understand also. So first one, we are going by the steps, so it will be easy for you. Let's see how we can solve. First question is, two particles of masses 1 kilogram and 1.5 kilogram are placed at a separation of 50 centimeter. Assuming that only one force is acting on the particle or their mutual gravitation, find the initial acceleration of two particles is the question. What are the things which you have to underline? I will read once again. Two particles are separated by 50 centimeter. Assuming that one force is acting, that is gravitation. So underline mutual gravitation. Okay. Then find the initial acceleration of the particles. That also you have to underline. What is that? Initial acceleration. So these 2 points you should have an idea. Or these 2 points makes you a sense about this problem. What is that? You will come to know that immediately it is a problem based on gravitation. Okay? And the second thing is, acceleration also has to be found out. These are the 2 important terms which will be striking in your mind when you are reading this question. Okay, so how can we solve? Then the second point, that is drawing the diagram. Two particles, 1.5 kilogram. Okay, they are separated by distance 50 centimeter. Now it is clear for you, isn't it? It is clear now. We are drawing. We have drawn also. Now you have to write the terms which we know. What are they? M1, 1 kilogram. M2, 1.5 kilogram. Separated by distance D or R is equal to 50 centimeter. These are the one which have been given. And the fourth point is, conversion is needed. You have to do. What is this conversion needed? For 1 kilogram, no need, because it is in kilogram and this is kilogram, but this is in centimeter. Have to be converted into meter. How can it be? 50 divided by 100 is give you 0.5 meter. Okay? Okay. Then what? You have to find the initial acceleration. For finding the acceleration, you have to find the force. Is the force given? No. So what is the way to find out force? Equation F is equal to capital G M1 M2 divided by R square, isn't it? For that, G value should be found out. The G value is the one which you know already, isn't it? What is the value? Gravitational constant G is equal to 6.67 into 10 raised to minus 11 Newton meter square divided by kg square, isn't it? So applying everything, we will find F. F is equal to what, ma? 6.67 into 10 raised to minus 11 into 1 kg into 1.5 kg divided by 0.5 meter whole square. Okay. If you are solving 6.67 into 10 raised to minus 11 into 1.5, because 1 and 1.1 is multiplied, right? 6.67 into 10 raised to minus 11 into 1.5 divided by 0.25. If we are solving, we will get the answer as 4 into 10 raised to minus 10 Newton. 4.002 something we will be getting. So 4 into 10 raised to minus 10 Newton is a force. So what do you understand by that? This is a force exerted by the first body over the second and the second body over the first. Isn't it? This is the force in between these two. So this is a force by which both the bodies are exerting on one another, each other. Okay, ma? What do you have to find out? Initial acceleration. So there also we have to apply formula. What is that? F is equal to ma. So first we have to find the acceleration 1. For the first particle, what is the acceleration? How can it be found out? A1 is equal to F by m1, isn't it? That's equal to, what is F? It's common, 4 into 10 raised to minus 10 divided by 1 kilogram. What will be the answer? Is equal to 4 into 10 raised to minus 10 meter per second square, isn't it? This is the acceleration which is exerted by the first body towards the second. Okay? Did you get, ma? Now applied by the second body. A2 is equal to what? A2 is equal to F by M2 is equal to what? 4 into 10 raised to minus 10 divided by 1.5. What is the answer? 2.66 into 10 raised to minus 10 meter per second square is the acceleration exerted by the second body towards the first. Now we have solved this problem. Okay, understood? I think it's clear for you. We are going to see the second problem. Now the second question goes like this. An object weight 24 Newton when measured at the surface of the earth. What would be its weight when measured on moon's surface? Okay, a body which weighs 24 Newton on earth, what will be its weight in moon is the question. What all things you have to underline initially? You have to underline at the surface of the earth 24 Newton. On the surface of the moon, find out, isn't it? Surface of the earth also and surface of the moon also. From this we will have an idea that it is the weight on earth and what will be the weight on moon. Okay. Then second point is to draw. There is no need to draw the diagram. The earth surface, moon surface, it's of no need of it. Okay. Third point, write the important values. What are the values given? Weight on earth is the only one given, isn't it? Is equal to 24 Newton. Fourth point is, if conversion is needed, we have to do that. Is the conversion, any conversion needed? No conversions needed. Now, fifth point is, write the unknown value. Weight on moon is the question, isn't it? Okay. What is the next point? Write the equation for solving it. What is the equation? Very simple. Weight on moon is equal to 1/6 of weight on earth. Isn't it? So, 1 by 6 into 24. What will be the answer? 6 ones are 6, 6 twos are 12, 6 threes are 18, 6 fours are 24. So the value will be 4 Newton. How easy it is, right? It is the way to solve the equation. They are quickly going to the third problem. The question goes like this. Mass of object is 10 kilogram. What is the weight on Earth and on Moon? What is given? Mass has been given. Is there anything to underline? Yes. On Earth and on Moon. Mass also you have to underline. Mass is 10. So, weight on Earth and on Moon has to be underlined. So, these are the important terms. Mass has been given. So, what you are understanding from this question? The thing which we are understanding is mass remains same everywhere, isn't it? But the weight, will the weight remain same on Earth as well as in Moon? No, the weight changes. Why? Because of the gravity exerted on the surface of the planets, the weight will be changing, but the mass remains the same. So, they have given the mass as 10 kilogram, right? Mass 10 kilogram. Weight on Earth. How can it be found out? What is the equation? Weight is equal to mg, isn't it? What is m over here? 10. What is g? G, acceleration due to gravity, will be 9.8. So, answer will be 10 into 9.8. What will be that? 98. 98 Newton. Why Newton? Because weight is equal to the force exerted. So, that is 98 Newton. This is the weight on Earth. Okay. Then the question is, what is the weight on Moon? How can it be found out? Weight on Moon. In the last problem, we have seen weight on Moon is equal to weight on Earth divided by 6. Isn't it? So, the same thing. 1 by 6 into weight of the object on Earth. That's equal to 1 by 6 into 98. This is 98, right? So, what will be that? It will be something like, how can it be cut off? Let's see. 138. Point 20. 20 means 3, 5. 16.35 kilogram. Newton. 16.35 Newton. Now the fourth problem. An object is thrown vertically upward at a height of 20 meters. Calculate. First one, velocity with which the object was thrown upward. Second one, time taken for the object to reach the highest point. Okay. The question have been read. What is the important things which we have to underline? Object is thrown vertically upward. So, underline the word upward. Velocity have to be find out and time taken. These three things has to be underlined. Okay. Upward, velocity, time taken. Okay. Now, draw an object. This is the ground. This is the ground. And object is thrown vertically upward. Object reaches maximum height, isn't it? This object reaches maximum height. Okay. So, what you are understanding from it? Object is vertically thrown upward. So, what will be the acceleration due to gravity? Is it negative or positive? It will be always negative because it's gone up. Acceleration will be negative. A is equal to minus g over here. Okay, then initial velocity is what? U is equal to what? Is not having idea. But V is equal to what? V, velocity at the end when it reaches the top. When it reaches the top, velocity becomes 0. Then what happens? Then only it will be exerting force by the gravity. That's why it will be coming back, right? So, V will be equal to 0 when it is reaching the top. Okay, so we are getting some ideas when we are drawing things. Okay, ma'am. Now we are going to see the problem. Answer. What is the measurement which is given? Height S is equal to 20 meter. Then what all things? We know V is equal to 0. A is equal to minus G. For our convenience, it is 20, no? So we can take it as minus 10 meter. 9.8 is almost equal to 10, but when we are applying it as 10, it will be easy for you to divide and all. That's why we are taking for our convenience. Find out the velocity. Initial velocity is what? Is the first question. And second question, time taken t is equal to what? Okay. How can we solve this kind of equation? So problems. We can solve by this way. V square is equal to u square plus 2as. Here V we know, A we know, S also we know, U we have to find out. Okay, ma? So what will be u square? We are taking this on this side. So V square minus 2as is equal to u square, isn't it? So what is V? V0. 0 square minus 2 into what is A? Minus 10 into what is S? 20 is equal to u square. That is what? Minus of minus positive. Minus of minus will be plus, right? 2 into 2, 4. 400. 0 and 0. 400 is equal to u square. What is u, ma? U is equal to 20. So initial velocity is 20 and the height also is 20. Root 400 is what, ma? 20. That's why we are getting u as equal to 20. Okay, ma? So u 20. Now second question is time taken has to be found out. Time taken, how can it be found out? Because all the things is known, V is known, U is known, A is known. So we can apply V is equal to U plus AT. It's become convenient to find out. 0 is equal to 20 plus minus 10 into T. Isn't it? So it is going to this side. So negative will become positive. 10T is equal to 20. T is equal to 20 divided by 10 is equal to 2 seconds. 2. As the time is in second, it is 2 seconds. So this is how we have to solve this kind of problems. Okay, ma? This is how we have to solve this kind of problems. Now we are seeing the fifth problem. A ball vertically returns to the thrower after 6 seconds. Find A. Velocity with which it is thrown up. B. Maximum height with which it reached. C. Position after 4 seconds. Okay. So what are the important things which we have to underline over here? Vertically returns. The ball is vertically returning. It is returning from the highest point after 6 seconds. Okay. Then the important thing is we have to find velocity, then maximum height, then position. So what you are understanding from this? We are understanding something that a ball is returning to the thrower. So the thrower is throwing the ball and it is returning back. Okay. So he has to throw and it will be returning back to him. Is there any displacement? What will be the displacement? From here it is thrown out and here it is coming back. So the total displacement will be 0, isn't it? Then what all thing? It is thrown upward. Then only it is coming back. So what will be the acceleration due to gravity? Acceleration is negative because it is thrown upward. So acceleration is negative. So these things you are getting. Now you have to draw. Then only it will be easy for you to understand. So this is the position of the hand of the thrower, and he is throwing the ball and it is returning back to the position. So displacement, net displacement will be 0 and it is thrown up where v will be is equal to 0. Initial velocity is equal to 0, it is a value, and what all thing, a is equal to minus g, and total displacement s is equal to 0. Total displacement will be 0. So all these we are understanding. Now we are going to solve the problem. How it can be? Vertically returns after 6 seconds. Time is given. Total time is equal to 6 seconds. Isn't it? Total time is 6 seconds. So which equation we can use here? If we are calculating the velocity, initial velocity by the first equation, v square minus u square is equal to 2as, it is not correct because the velocity is not 0. If the ball is thrown upward only, then the velocity in the upside part velocity will be 0. But as the ball is going and it is returning back, we can't say that v is 0. So instead of that, we can say that s is equal to 0 because it is going up and it is coming down to the same position. So displacement is 0. So which equation we can apply over here? S is equal to ut plus half at square is the equation which is applied over here. Here a is equal to minus g. So the equation is changing in this manner. S is equal to ut minus half g t square. It's equal to, apply all the form, s is equal to 0. U is equal to what, ma? U is the one which we have to find out. And what is t? T is equal to 6 seconds. 6 minus half into g is equal to, we are taking for our convenience as 10. 10 into t is equal to 6 again. 6 square. Isn't it? By this way we can find out velocity. So this is 0. So I am putting this in opposite side. Half into 10 into 36 is equal to what, ma? 6u. So u is equal to what, ma? 5 into 36 divided by 6 is equal to 5 into 6 is equal to 30. 30 is what? Meter per second. The ball is thrown with the initial velocity 30 meter per second. Then only these things have happened. Okay. Second one, maximum height. I have said the displacement is 0, but I didn't say that maximum height is not reached. Maximum height is entirely different from the displacement. Displacement is 0. When the ball is going up and when it is coming back, the displacement is 0. But the ball is coming up and reaches a position, no. That position is what? Is the question. So how can it be found out? We know one thing. When the ball is reaching to the maximum, what will be the final velocity? Final velocity will be 0 over there. Okay. So what will be the equation which we can use? We can use the equation as v square minus u square is equal to 2as. Here alternations can be made, that is v square minus u square is equal to minus 2gs. Okay, what we have to find out? We have to find s over here. S means maximum height. So in the maximum height, when it is reaching, v will be 0. 0 square minus, what is the u? U we have found out as 30. 30 square is equal to minus 2 into 10 into s. So I am taking this side and this and that side. So what will happen? The negativity will be gone. 20s is equal to 30 into 30. Isn't it? So s is equal to what, ma? S is equal to 30 into 30 divided by 20. 0, 0 cancelled. 30 by 2 will be 15. 15 into 3, 45 is equal to 45 meter. Which means what? Which means the ball have reached 45 meter as its maximum. It is the maximum height reached by the ball. Okay. Is it clear for you? Okay. So the ball have reached the maximum height of 45 meter. Okay. Now the last one is position after 4 seconds is the question. How can we find it out? Position of the ball after 4 seconds. Actually, the ball is taking 6 seconds to go up and to come down. Do one thing, throw your pen or pencil to a little extent. Just see to which extent the ball is thrown up, to that extent the ball will be coming back. So, when we are dividing the 6 seconds into 2, 3 seconds will be taken by the ball to go up and again 3 seconds will be taken by the ball to come back. Okay, it is the way. So, what will be the position of the ball they are asking after 4 seconds? Where will be the ball, ma? After 3 seconds it may have reached all the maximum height. Then on the 4th second it may have reached almost here. Isn't it? 5th second here and 6th second will be back. Like that. So this will be almost here at this position. So what is the height or the position? The position means the height only. The height with the ball have reached at the 4th second is the question. So how can we solve it? The same equation, S is equal to ut plus half a t square. Here t has changed from 6 to 4. Here t is equal to 4. U we know that 30. U is equal to 30 meter per second. A is equal to, here also A is equal to minus G is equal to minus 10 meter per second square. Then what will be S? Is the S 0 over here? No, because at the position after 4 seconds the position is not 0. It may have reached some position. What is the position? We are finding it out. Okay, ma. So S is equal to what? Apply all these. 30 into 4 plus or minus, because it has been altered, right? Minus half into 10 into t. What is t, ma? Again it is 4 squared. Okay. We are solving it, isn't it? Is equal to 30 into 4 is 120. 120 minus 4 into 4. 4 into 4. 2 is cancelling 4 and we are getting to 2 into 4, 8. 8 into 10, 8 into 10, 80. 80 is equal to what, ma? 120 minus 80 is 40. 40 meter. What we are understanding from it? We are getting the answer as 40 meter. Means maximum height is 45 meter and in the 4th second the ball is returning back and reaching the height of 40 meter. I think that the problem is clear for you. Okay? Now we are moving quickly to the 6th one. Here's now the 6th question. What is the magnitude of the gravitational force between Earth and 2 kilogram object on its surface? What is the magnitude is the question. What? Between the Earth and 2 kilo object. Okay. So what all things we have to underline? Magnitude of gravitational force. Okay. An object on surface. On surface is very important. It is there on the surface. So what you are understanding by that? Means that object will be having of only force between Earth and the object. That is gravitational force will be acting on the object. Isn't it? Okay, these things. Is there any need of drawing diagram? If you want, you can draw Earth and object on the surface. Okay, this is the diagram. Now what? Now we have to write all the things which we know. Mass of the Earth. It is given as 6 into 10 raised to 24 kilogram. Okay, capital M we found out. What is small m? Small m is equal to 2 kilogram. Okay. And radius of the earth R is equal to what? 6.4 into 10 raised to 6 meter has been given already. Okay. So, is there any change to be made or any sign conversion has to be made? No need. Everything is in proper form. Now, what is the equation which we have to substitute over here? F is equal to what, ma? F is equal to G capital M small m divided by R square. Isn't it? What is G? G is the universal gravitational constant and value of G is equal to 6.67 into 10 raised to minus 11 Newton meter square per kilogram square. So apply everything, we will get the answer. Let's see what is the answer. Is equal to 6.67 into 10 raised to minus 11 into 6 into 10 raised to 24 into 2 divided by 6.4 into 10 raised to 6. Again into 6.4 into 10 raised to 6. That is 2 times means this. Then this number you can multiply and divide. There is no problem in it. But what about the 10 raised to 11, 10 raised to 24, 10 raised to 6, 10 raised to 6 and all? All these we have to find the answer now itself. Then it will be very easy for you to find quickly. Minus 11 plus 24 will be what? 24 minus 11 is the answer, isn't it? 4, 1, 4, 3. So plus 13 is in the numerator and 12 is in the denominator. 6 plus 6 is 12. So plus 13 minus 12 is what, ma? Plus 1. That is 10. Okay, that will be 10. Okay, that is 10 raised to 1. Okay. Then 6.67 into 6 into 2. That is 6.67 into 12 divided by 6.4 into 6.4 into 10. Isn't it? This is the answer. So what we are getting when we are multiplying and dividing? We are getting the answer as 19.34 Newton. I think it's very easy problem to solve and we have solved it. Okay. I think we have gone a lot through the numerical problems in gravitation. We can meet in the next class. Bye.